Hello, intrepid geonauts. Today we are going to be working on the Ocean and Coasts Science Interactive Lab. So let's go ahead and get started. So this is the lab that we're working on, Oceans and Coasts. You can see that oops, it logged me out. You can see that we don't need a whole lot of materials for this. So let's go ahead and get started. Exercise 1 requires Google Earth Pro. By this point, you should have that downloaded from previous labs, but either way, if you don't have it yet, just download it and install it. Then we open our coastal vulnerability file. Mine is downloaded. Once it's downloaded, you open it and Google Earth should open. Now we're going to take a look at the Assateague Island data and Goosefair Bay data. So all I did over here, I'm bringing this over here, is it'll be under temporary places, expand, 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 like that. Double click, double select the connected diamonds icon for the Assateague Island profile and the sidebar to display the profile line on the map. So we're going to go back over here. Mine's already clicked. I'm going to go ahead and I am going to zoom in on this. Mine is already selected. I'm just going to take that off so we can see it without that. So this is the profile line. If you zoom in, it should say at some point that this is for finding the profile. There we go. If you click on it, use to calculate coastal slope. So right click on the island profile link in the sidebar and select show elevation from the drop down menu. So that's this right down here. So all I did was I right clicked it and it opened up as an option. So some people were confused by this. You need to convert your 19 meters into kilometers for number 11. I've gotten a couple of questions about that. So there are 1,000 kilometers there's 1,000 meters in a kilometer. So all we have to do is take 19 and divide it by 1,000. And that's the change in elevation in kilometers. So you're going to want to record that in data table 1. And then you're going to want to select the Ocean City data station link. Now, during the government shutdown, this link was difficult to use. No matter what, it's easiest to go ahead, highlight the link, right-click it, copy, and then paste that for best results. So the government is open again. That gives you a timing. This is exactly on Thursday morning that I'm recording this. And this gives you the data that you need. Now there is a question down here that is asking you to look at sea level trends. That is no longer under this. It's no longer under tides and water levels. It's under sea level coastal flooding. So that's where you click on for that. Going back over here and walking through this. Over here for displaying for analyzing the changes in profile due to erosion, what you're going to want to do is make sure this button is clicked. If that button's not clicked, these lines won't show. And if these lines don't show, then you don't have the data that you need. So notice that the color is associated with the year. So the red line is 1849 and the purple line is 2000. Keep in mind that 1849 to 2000, that's 151 years. So when you do your calculation, the number out down here is 151 years. So once you have your numbers, you're going to have to give it a vulnerability rank. So let's just do our vulnerability rank for our coastal slope. We know that our coast back over here is 15. 15 is on the bottom. 0.019 is on the top. So we open up our calculator and the calculation is 0.019 is our top number divided by, because that's 19 meters in kilometers, divided by 15 kilometers, which equals this. Now I'll compare that to my data over here. And for coastal slope, we can see that we have a sandy beach, a barrier island, delta coral reef. We have a very low slope, so our coastal vulnerability just based on our coastal slope is very high. And so for each one of these numbers, you will be able to assign a very low, low, moderate, high, or very high coastal vulnerability index, and then do this last calculation down here, where you just go ahead and you multiply all those numbers together and you divide it by 6. Here, what type of surface currents are affecting, are they exposed to, and what direction do they flow? A student came down and asked, I assumed that this was in one of the tables. It does not appear to be. So, I would just go ahead and say longshore current. That's what you're exposed to here. That's the longshore current that's causing littoral drift. Let's go ahead and take a look at the next exercise, which is the exercise over here, exercise number 2. So we're going to resume this and we're going to take a look at these different animal tracks. And for example, here is our friend, the elephant seal. Very unfriendly critter. Cool animal though, but very aggressive. So this is really just taking the information here and putting it down here. Now maximum daily depth. So average depth they give you for the average depth of our elephant seal, that's 341.79. The range is the difference between the max and min. So in this case, it's 715 minus 125, which is 590. So for elephant seal, this would be 590. And average depth is 340, we'll say 342. Rounding is okay. We're not going into how to round correctly in science, so just like a good rule of thumb is 2 decimal places is pretty good. But if you have a big number that has 3 digits in it, just go ahead and round to the nearest one. So to find the answer to this question, where would they be classified? That's pretty straightforward. That's taking those numbers and looking at these values in here. You can copy and paste this image in another screen. It might be useful because clicking back and forth can be painful. So you can actually download this image and then open it up with another app so you don't have to click back and forth, because I know, at least in my view, Science Interactive does not like multiple windows. So I can just open this up. And now I have the diagram I want while I answer the questions side by side if I want that. So I hope that helps. Don't be afraid to reach